In our last video, 3-2, we started talking about the 5-number summary for a collection of data. Normally, a collection of data might be quite large, very many numbers. So we don't want to look at all the numbers and try to make decisions or draw conclusions. It is very hard to digest a large data set. We are used to finding things like the average of numbers and this sort of idea, use this idea to summarize a large collection of data. In Unit 3, we're going to use 5 numbers to summarize a large collection of data. The 5-number summary. The 5-number summary divides our data into 4 groups or intervals or regions. These 5 numbers, the minimum, first quartile, median, third quartile, or 3/4 of the way through the data, or 75% of the way through the data, and the maximum. These 5 numbers break us up and break our data up into 4 regions. Each region has 25% of the data. You can think of us as dividing the data up nicely like a pizza. When you have a pizza, sometimes a small pizza you divide into 4 pieces. Each quarter of the pizza, each quarter is 25% of the pizza. So we're breaking our data up into 4 25% pieces. Now, in our last practice, we looked at some data, and luckily we have our data in order and we have it numbered. This makes for finding the 5-number summary quite easy. The smallest number, of course, the minimum is right at the beginning, it's 5. The maximum is right at the end. The data is in order from smallest to largest. The maximum is in the end, 52. The middle number. Can we be sure of the middle number? Why don't we remember that the middle number might use this formula, 1/2 n plus 1. Where did this formula come from? Remember, for a percentile, we have p out of 100 times n plus 1 to find the position of a percentile. And the median is the 50th percentile. The 50th percentile. And so we might use 50 out of 100, which is the same as 1/2. How much data do we have? 23. So 23 plus 1 is 24. 1/2 of 24 is 12. The median is the number 35. Once again, we have a trick. N is 23. It's an odd number. So to find the first quartile, we can do the median of the lower half of the data. The middle number of the lower half of the data is 26. That's the first quartile. The middle number of the upper half of the data, that's 38. That's the third quartile. There's your 5-number summary. And now, if we were to graph these 5 numbers, on a number line, we would see that our data, if we make a dot plot of our data, the lowest number is 5, the largest number is 52. Each one of these dots corresponds to a piece of our data. There's 3 37s. There's 3 dots here above the 37. And there's approximately 6 dots in each one of these intervals. Approximately 25% of the data is in each interval. You can see the intervals are different sizes, not like the nice sizes of our slices of pizza. So, our data, the range of our data from 5 to 52, you can find the range as the maximum minus the minimum, 52 minus 5, 47. So our data ranges across 47 units. However, there's this thing called the interquartile range, the distance between the two quartiles. 26 is Q1, 38 is Q3. There's 25% in each of these regions. 50% of the data is in the interquartile range, the middle 50% of the data. You might think of it as the reasonable data. Maybe there's something wrong with this number 5. Maybe it's a little bit too low. 52, why is it so big? These numbers seem to be clustered in the interquartile range. 12, that's the distance from Q1 to Q3. The interquartile range, IQR, interquartile range can be computed as Q3 minus Q1. It's a smaller distance. The big range is 47 units, maximum minus minimum. The distance between the maximum and minimum. The distance between the two quartiles is much smaller, 12 units only. On page 69, we have an example, much like what you might see as an exam question. We're given a chart. There's some data in the chart. When you want to answer questions regarding a chart of data, it is quite convenient, of course, to understand what sort of data is in the chart. There should be a title in the chart. So apparently a group of students are guessing answers to a quiz. Possibly this quiz contains subject matter that they are not familiar with. And so as an experiment, they are simply asked to take this quiz and guess the answers. And then we will get some data and graph the data. So we are interested in the number of correct answers by each student. For example, how many students got exactly 3 correct answers? What is the height of this column? The height of this column is 5. There were 5 students that got exactly 3 correct answers. That would be the data that we'd be collecting. We would collect all these tests from the students and mark them and see how many correct answers they got. The data might look something like this. If we order it, 2 students got exactly 1 correct answer. 3 students got exactly 2 correct answers. And then there's 5 students that got exactly 3 correct answers. And so it is this data that was put into a column chart. And you can see that the biggest column is above the 5. That's the column with the highest frequency, the highest number of students. The highest number of students received 5 correct answers on this test. So, let's set out to answer these questions. How many students guessed exactly 7 answers correctly? The number of correct answers, this is on our x-axis, 7. How many students guessed exactly 7 answers correctly? The height of this column is 3. How many students guessed all 10 answers correctly? What is the height of this column? Only 1 student was lucky enough to guess all answers correctly. Were there any unlucky students? How many guessed all 10 answers incorrectly? All 10 answers incorrectly. In other words, 0 answers were correct. Well, the height of the bar here, you cannot see a column, so the height must be 0. 0 students, or nobody guessed all answers incorrectly. How many students were in the experiment? Well, there's 2 here, 3 here, 5 here. The next column has 6. The next column is 1 higher. There's 7. And now there's 4 students that got exactly 6 answers guessed correctly. 3 guessed 7. 2 students guessed 8 answers correctly. 2 students guessed 9 answers correctly. And we have to add these numbers up. 2 and 3 is 5, and 5 is 10, and 6 is 16, and 4 is 20, 27, and 3 is 30, 2, 4, 5. 35 students were in the experiment. Now, if we did have a collection of data written down like this, sometimes you get asked for things like the median. What is the median of the data? Can we answer that question without writing all this data down? Can we answer it just from looking at the chart? I want to show that the median is in the 18th position. How do I do that? Remember our position formula for a percentile? The median is the 50th percentile. The 50th percentile, the median is, remember, halfway through the data. 50 out of 100 is the same as 1/2. N plus 1, there's 35 pieces of data. 35 plus 1 is 36. Half of 36 is 18. The median is the 18th data item. Now, how many data items did I write down? Not 18. Can we find the 18th number just by looking at the column chart? Well, there's 2 1s, 3 2s, that's 5 numbers, another 5 is 10, and then 6 is 16, 17, 18. The 18th number is sitting there. If I wrote them all out, the 18th number would be a 5. The median is the number 5. The first quartile. Using this formula, once again, the first quartile, the 25th percentile, 25%, remember, is 25 out of 100. 25 out of 100 would be 1/4. To find the first quartile, we're looking at 1/4 of the way through the data. 1/4 of 36. The 9th data item. The 9th data item is the first quartile. What is the 9th data item? I think I have the 9th one sitting here. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9th data item is the 4th 3. How would we have found it from the chart? 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9th data item is the 4th 3. First quartile is 3. We're eventually going to want to make the 5-number summary. The smallest number of correct answers anyone got, the minimum of the data is 1. The first quartile is 3. The median is 5. What's the third quartile? The third quartile is 3/4 of the way through the data. N plus 1, 35 plus 1, again, 36. 3/4 of 36 is 27. The 27th data item is the third quartile. Well, that'll be a little bit of work to find the 27th data item. There's 2 here, and 3 is 5, and 5 is 10, and 6 is 16, and 7 is 23. I want the 27th. 23 data items here, 24, 25, 26, 27. The fourth 6, if I wrote these numbers out, the 4th 6 would be the third quartile, Q3. And the maximum of our data, if I wrote all this data out, the final number, there would be 110. That would be the maximum of our data. That would be the one person that got all 10 answers correct. There would be 110 in our data. And so there's the 5-number summary of this collection of data, which we didn't really write out, but it's here in our table.